All right, so for this example, we're going to solve a logarithmic equation both algebraically and graphically. And so with this one here, one thing you notice is that we have a log that's a base 6. Okay? Now normally our calculator works in log base 10, but we know how to use the change of base formula. So we're going to need that a little bit later. But first of all, let's focus algebraically. You should remember there's one kind of tip or rule that if you have the log of base whatever equaling another single term that's log of base the same, then these parts of the logarithm are equal to each other. That make sense? So if you have two terms on the either side of the equal sign, they're both logs and they both have the same base, then you can let these expressions or numbers equal each other. Okay? So algebraically, this one's pretty easy. We don't have to do a lot of steps ahead of time. You can go straight to the fact that 2x minus 1 should equal 11. Okay? And if you don't believe me, let's see. I think this was back here in the key ideas. Right here, wasn't it? Yeah, if log of L base C equals log of R with the same base, then L equals R. So that's a little tip that we talked about yesterday. So what is x here? You could probably do this in your head even. X is going to be equal to 6. Okay, good. Add 1, that becomes 12. Divided by 2, 6. All right, so that's easy, algebraic. Pretty straightforward. The problem is graphing this. Okay? Now we know that we can graph the corresponding functions for each side, but our calculators generally don't do base 6. So you want to remember something. The change of base formula. So log of a base b can be written as the log of a base c, that's any other base, divided by the log of b with the same base. And so if we choose this as 10, let's say, then we can use our calculators with a common logarithm. So we have to keep that in mind when we graph the change of base formula. Okay, so having that in mind, let's get the calculator up here. Let's go to y equals. And if we're going to graph this, y equals, what we have to do is we have to say, I want to graph log of 2x minus 1 base 10 divided by log of 6 base 10. That's how you graph that. Okay? So we do, and we're going to use lots of brackets here. So log of 2x minus 1 divided by log of 6. Sorry? So this is what I've done. Let me show you what I did here. I'll just kind of let me just redo this. So I've done log of 2x minus 1 with a base of 10, that's what my calculator is programmed in, divided by log of 6 base 10. And that's how I can express this. It's the same thing. All right? And then, of course, over here, this one is going to be log of 11 base 10 divided by log of 6 base 10. Okay? So those are my two. So we go down here and we just do that. So log of 11 divided by, I don't know if I need brackets there, divided by log of 6. Okay? Now if I graph that, let's see what happens. Okay? So there's my first one. And here's my second one. Now this is a horizontal line. Does that make sense that this is a straight horizontal line, or should it be kind of a logarithm looking line? Did I do something wrong, or does that look okay? It's okay? Not okay? What'd you say? It's okay. It's okay? Yeah. Okay. Can you tell us why?
Because rows 11 is one number.
Right. Log 11 base 6. There's no variables in here. This is just a number. Yeah, see that? That's just a number. Log 11 base 6. It's just a number. So if you're doing y equals a number, that's going to be a horizontal line. Okay? So I won't bother zooming in there. You could zoom in, but we can see there's going to be probably an intersection point here. Now, how do we get our calculator to do that? Again, pretty easy. Second function trace. Get it to calculate the intersection point. It'll show you the first one here that we put in. Yes. Show you the second one. Yes. Wait. First curve. Oh, did I only put in one? Let's try that again. Weird. Usually it just pops to the second one when you hit enter, but it didn't. Okay, my calculator is messed. Okay, so we may have to zoom in. The calculator just didn't pop back and forth here. But anyway, so we've identified the two curves and we wanted to guess. And so it'll guess the intersection point somewhere, looks like over here, right there. And of course that's at x equals 6. So that is the number that we got over here algebraically. Okay, so that's how you graph something that's a logarithm that is not base 10. Use your change of base formula. Okay, find the intersection point.